But what I want to do is build a watertight cylinder for a submarine, and I want to put a piston on either end. Then I want to mount with each piston a distance sensor, so that I know exactly where the piston is on either end of the cylinder. And I'm also going to add to it, as I've done with my other boats, a pressure gauge. And between those three things and an Arduino, I want to be able to control this submarine really well. Now, I do have a bit of an issue doing this because I want to get into it, but the problem is I'm a scratch builder and I don't have a spare submarine lying around. I've got the Nautilus, which is just the right shape to do this, and I can replace what I've already put into the Nautilus in order to demonstrate this. So that's actually what I'm going to do, but that's left me with a couple of dilemmas about how to do that because of how the Nautilus is currently constructed. So this, I'll just quickly show this to you. The Nautilus currently has a cylinder at the stern in which the motor and the battery sits and a few other bits and pieces. And then next to that I've got another cylinder, and the end cap has a pump that pumps water in and out of the ballast tank, which is there. In the ballast tank there is a piston that gives me fine control, and then this particular part just couples onto another piece that's got all of the electronics in it. Now that's how that basically works. So my thought is, without wanting to completely rebuild this boat, is to do this, is to keep the main pump in, pump out tank, but to build the piston right in here, and then to have the other piston there. Now, the fact that the piston isn't at the far end and this piston is close to the bow really doesn't matter. We can control that just as well. But that's how I plan to do this. So what we're going to do, first of all, is we're going to build the pistons. Now, I'm just going to say this. Obviously I've got a lathe, and that makes a huge difference. Once you've got a lathe, you can do this stuff really cheaply. I think these pistons in total are going to cost, even with the sensors, are going to cost about 30 bucks each. That's, you know, plus other materials and other stuff that you get from a plastic manufacturer and things like that, but they're really not that expensive. So it's going to be interesting. We'll build the pistons, we'll build the gearboxes, boxes that are going to sit there, and you know, so that the motor can power them. We're going to begin by doing a small demonstration one. I just want to make sure that the way I'm going to build this is going to work before I invest in building a whole new one. Then we're going to start playing around with the Arduino a bit and just getting that sensor working. And then I'm going to build the whole thing, and I'm going to test it to start with. I want to make sure that the pistons and the way that they're constructed will work in at least 2 meters of water. And then we'll replace it all, and it's going to be really quite interesting. So if what you want to do is to build a watertight cylinder with a piston at either end, this is a good way of learning how to do it. Also, it is very clear to me that if you've got a major, this is your major watertight cylinder, you can make the piston smaller at either end, because it tends to be that at either end of the boat you've got less room. So that easily will work the same way, because the gearbox and so on will still fit in there. And the other thing that I'm going to do is build a connector in the middle, which once again will be, it'll have O-rings and it will have a connector, and we'll probably have to have some method of holding it all together so it doesn't go pop when the pistons come in. There you go. So we're going to get into that process now, and most of this is going to be an exercise in practical building stuff on the lathe. So let's go. Alright, so here are my raw materials. I've got some, I think it's about 22mm plastic, some 10mm plastic, some 6mm acrylic that I'm going to use to make the bulkheads. And I've just drawn them out, a little bit oversized, and now just using my cutter here to cut them all. And this does a remarkable job even with the thick material. This is going to be a very interesting process, and I've thought a fair bit about how to do this and what the best way of doing it is when you've got a small lathe. And I think this is practically foolproof. I can't believe that this tiny blade does this so well, but it does. There we are, back to normal speed now. And these are going to be the pieces I'm going to use for the pistons. I'm a bit concerned about how thick they are. I'm not sure that they're going to be all that effective. What I'm going to do now though is just make a piece of brass, tap it out nice and squarely right through the middle, and this is going to be a mandrel which is going to enable me to work on all of these pieces far better in the lathe. It's always worth doing a little bit of preparation before you do something like this. I'm using 6mm stainless thread, and that's going to be the material that's going to work with the pistons. So the trick now is just to put a point in the center of all of these items that I have built, and the next thing that I'm going to want to do is simply drill them all. Start off with a center drill. It's the best way of doing this. Then putting a drill through, which is good for cutting a thread, and I put it through all of them. And now I'm going to use the drill press, interesting technique here, to put this thread through each of them. Now you're probably wondering why I'm threading them all. This is going to make sense as we go along. And I must admit, it really has been a bit of a winner of a process, not only for mounting in the lathe, but also for lining up the gearboxes. And you'll see that when we get to it. So I just want these threads nice and square, running through the middle of all of these pieces. Okay, there we go. Now I'm going to use a piece of thread and my mandrel and a couple of nuts on here. And this is now what I'm going to put onto use to mount these pistons onto the lathe. That's it. Happy with that. Needs to be nice and tight. The trick, of course, with this is never to take a bite that's too deep when you're using the lathe, because that's as it's just on there with the power of the thread and the bolts. Now you can see that washes out of line, but in fact the bolt is nicely in line, and I've used my dial gauge to get that perfectly right, so that I can now begin to machine the outside sides down. If you've seen me make pistons before, you'll be fully aware of the process here. I machine that down until I get a nice sliding fit, and it's not ready yet with this. And I'm just taking, a couple of, maybe 1 or 2 thou off per cut at this point. It's a bit like angel hair here, just to get it to the point where I get this really nice sliding fit, because now I can use my cutter to cut the groove for that O-ring practically perfectly. And once I've done that, then I can trim down the plastic of the piston a bit, because I don't need that to be even a firm sliding fit. It can be quite loose, as you can see here. But the O-ring needs to be nice. So I've got the first one done. In practice, I discover that this is still a bit too tight, and I'm going to have to trim it back. But you can see, even with a glass of beer, we're coming along quite well, and we're now going to do the next piston. And yes, we go through the same process. This all went without a hitch. Now I've got this thick piece, I think this is 22mm, and this is going to be the piece that sits in the middle of my finished cylinders, so that I can pull them apart in the middle. There's another purpose behind that. There's going to be wires coming out of this little thing, and they're going to come out through this. So I'm just developing the right thickness on both sides. You can see I've nearly finished that now, and that's a very, very nice fit. I'm very happy with that. That's going to be pretty good in the middle. So I'm now also making the bulkheads out of acrylic, and we're going to glue those in, or actually weld them in. I'm now taking the center out of that centerpiece, and here it is. Here are all of the parts that I want for my cylinders. Pretty happy with that.